everyone, myself Sravanthi, working as the assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today my topic is context-free grammar. So here I am going to discuss what is a context-free grammar, what are the regular grammars, what is a context-free language with examples. So what is a regular grammar? So there are four types of grammars are there. The regular free grammar comes under type 3 grammar according to Chomsky hierarchy. Nothing but the classification of grammars in that regular grammar is a type 3 grammar. So it is very restricted grammar and the predictions are in the form of alpha produces beta. Alpha produces beta. Here where alpha is nothing but it's consisting of non-terminals which is lying in the LHS part, and these alpha can be replaced with beta. Whenever in my string, whenever I see these alpha, nothing but these non-terminal can be replaced with the beta variables, beta productions can be replaced with beta, which is a string of terminal symbols. So here the beta is nothing but the beta is a combination of a terminal symbols or non-terminal symbol, terminal symbols, or terminal symbol followed by non-terminal symbol, and there can be a epsilon. So the beta can be a combination of, it can be a single terminals or it can be epsilons or non-terminals followed by terminals, terminals followed by non-terminals. So in this way the production rules are going to be written. So there are four tuples will be there in a regular grammar: V, T, P, S. So V is nothing but it consisting of the non-terminals set of variables, nothing but we'll call it as non-terminals which are written in the capital letters. T is nothing but the terminals, set of terminals, and P is nothing but the production rules. S is nothing but the start symbol. For in any grammar, there will be only single start symbol will be there. Like a finite automata. A finite automata consists of one starting state or initial state, and we can have many final states in a finite automata. In the same way, here also in the grammar also, S is nothing but the start symbol. In every grammar, there will be only one start symbol will be there. So the production rules will be in the form of alpha produces beta. From these alpha produces beta, from these production rules, we are going to take the start symbol. And these production rules are constructed with the help of V union T whole star. V union T is nothing but set of non-variables, nothing but the non-terminals, and T is nothing but the set of terminals or nothing but set of small letters. Terminals will be written in the small letters and variables will be written in the capital letters. And it is a combination of V union T is nothing but the production rules are framed with the help of terminals and variables, and P is nothing but the production rules. So let us see a few examples here. A produces AB. It is a terminal. Terminal is followed by non-terminal. Yes, it is true. Here A single terminal is there. This is also a regular grammar production rule. A produces epsilon. Yes. So A produces BA. B is nothing but the non-terminal and A is nothing but the terminal. Non-terminal followed by A, terminal followed by non-terminal, and we can have single terminal and we can also have epsilon. So this way we can have the productions in the regular grammar. So the next one is context-free grammar. So context-free grammar is nothing but it is consisting of a finite set of rules. Nothing but we'll have quadruple. We can call this four tuples. We can call these four tuples as a quadruples. The four tuples are nothing but the V, T, P, S, V, T, P, S. Okay, so where V is nothing but the set of non-terminal symbols, or we can also call it as variables, and these are written in the capital letters. And T is nothing but a set of terminals which are written in a small letters, nothing but lowercase letters, and where V intersection T is equal to null. Why where V intersection T is equal to null, or we can also call it as pi. V is nothing but it is consisting of capital letters and T is consisting of small letters. There won't be any intersection between the terminals and the variables. So we are going to get here pi or null. So P is a set of rules, nothing but P produces V union T whole star. So there can be 0 occurrences or 1 occurrences, or it can be a combination of terminals and variables. So these production rules are framed with the help of terminals and variables. S is nothing but the start symbol. This start symbol is written from the production rules. So let us see few examples. These are the some grammars are there. So this is nothing but the capital letter is there. This is nothing but the non-terminal. So we can also call it as V. And this is nothing but the terminal symbols. So it is T, and P is nothing but the production rules, which I have written over here. And A is nothing but the start symbol. See here in these production rules, I have the first production rule. The first production rule in the LHS part, that will be our start symbol. In the production rules, the first production LHS part, we are going to call it as a start symbol. See here, the second one. Here it is having a non-terminal yes. Non-terminal yes is there. And here I have A comma B. A comma B is nothing but here, this is a terminals, nothing but it consisting of small letters. P is nothing but the production rules. And S is nothing but the start symbol. S is nothing but the start symbol. Here we don't have these terminals in non-terminals. Only single S is there. Here the production rules are having S produces ASA, S produces BSB, S produces epsilon. By using these production rules, we can generate the strings. We can generate strings. Any number of strings can be generated. Nothing but the set of strings will be generated. Nothing, we can call it as a context-free language also. So the grammar, here I have, these are the production rules. From these production rules, we are going to frame V, T, P, S. So V is nothing but the set of non-terminals. I have S, S is one non-terminal, and F, F is also one non-terminal, S comma F. And what are the terminals? Terminals are nothing but the small letters. It can be numbers, or also it can be commas, open brace, closed brace. All those things comes under the terminals. So 0, 1 are nothing but the terminal symbols. And P is nothing but the production rules. All these comes under the production rules. And S, S is nothing but the start symbol. Here in my production rule, the first production is S produces 0, 0, S. So the first S will comes under as a start symbol. So this is nothing but the grammars for context-free grammar. We can also call this context-free grammar as CFG. CFG. So it is very important grammar. So to construct any strings or to do any parsing techniques, we will be using this context-free grammar. So let us see few examples of context-free grammar. Construct context-free grammar which accepts the strings having at least two A's over sigma equal to A comma B. Context-free grammar. Construct context-free grammar which accepts the string having at least two A's over sigma equal to A comma B. So here we are going to construct the context-free grammar. So grammar is nothing but we are going to construct the productions, and from that productions we are going to frame a four tuples, nothing but V comma T comma P comma S. So here we are going to generate the string that should accept at least two A's. So in my string or in my language, so collection of strings is nothing but we are going to call a language. Let me generate once few strings which are going to accept two A's. AA, it is accepted. ABA, it is accepted. BAA, it is accepted. BABA, it is accepted. So in this way, all these strings are going to be accepted. So I need to have at least two A's should be there. Here I need to have at least two A's. I can have more than two A's also, BA, BA. Yes, these things also can be accepted. So nothing but here, how I can construct the context-free grammar is, see here A. So these two are fixed. Nothing but I should have at least two A's I can have. See, A I can have, or B also I can be having, or three A's also can be there. So A plus B, A plus B. Here also I can have A plus B, and here also I can have A plus B. So how I am constructing? The condition they gave is it should have at least two A's. Two A's are mandatory, so I gave two A's, and initially I can have A or B, or A or B, or A or B. A or B. So nothing but A plus B whole star, A plus B whole star, A plus B whole star. So here how I can write? All the four A's I can have, or I can have BA, BA, I can have, or else I can have AA. So this is nothing but star is pointing to zero or more occurrences. Zero or more occurrences. So according to the given condition, I am getting two A's I am going to generate. Two A's I am going to generate. So from these things, we are going to construct the context-free grammar. So let us see how to construct the context-free grammar. So the context-free grammar productions we are going to construct. So let me take the common name as common letter as some variable, like you can take it as X or T, anything as a non-terminal letter you can take it. So let me take it as some T. So the common one is A plus B is there. A plus B is there. So the terminals as it is we are going to write here. So let me start it with S produces. The non-terminals can be any non-terminals you can take. S produces. S produces. So T, A, T, A, T. T, A, T. So how I have written? So T, A, T, A, T. T, A, T. I have written. So why I have written? Because here they gave at least two A's. Two A's are at least. And this T can be combination of A or B, or it's A plus B whole star, or I can take epsilons also. Now we are going to derive this T. T I am going to derive. So what we can derive? AT, A or BT, or I can have epsilon. Why? Because zero occurrence. If it is zero occurrence, nothing but T produces epsilon I can take. T produces epsilon we can take. So let me check whether this is able to construct the context-free grammars or strings, which is it generating the strings or not, we can check it. S produces T, A, T, A, T. So I can replace T with either AT or BT or epsilon. With anything I can replace. So let me replace with epsilon. Epsilon A, epsilon A, epsilon. Nothing but I got two A's. Yes. So let me replace these T with AT, AT, AT. Then A, epsilon A, epsilon A, epsilon. Three A's also I have generated. Let me replace it with BT. BT, A, T, A, BT. So B, A, B, B. These are nothing but T's are replaced with epsilon. So this grammar is going to generate any strings which is having at least two A's. So we are going to replace the common letters with some non-terminal, and then we are going to produce that non-terminal with some productions which we are going to replace that one. Here I have replaced A plus B. A power A, capital T, and I can replace it with BT, or if it is, let us assume, if it is zero occurrence, then nothing but it is epsilon. So this is the context-free grammar for the given question. So generate all the strings of A's and B's where every string end with A. So here the question A, it should end with A. So here in my grammar, the strings should end with A, and initially the starting can be a combination of A plus B whole star. I can have multiple A's or B's or combination of A and B, and I can also have zero occurrence of B. So this is the regular expression for this given question. So here for this one we are going to generate the context-free grammar. So how I can generate the context-free grammar? So let me take S. S produces. So I am replacing this A plus B with some variable X, and the non-terminal I am having X. Sorry, A. So these X I am again reproducing it with X is replaced with AX or BX or epsilon. AX or BX or epsilon. We can have epsilon. So in this way, this grammar is context-free grammar is generated for this given string A that should end with A. See here, it is ending with A, single A. X can be replaced with one time. I can replace it with epsilon. So one time I can have two A's, or I can have BA or BBA. Anything we can have. So all the strings are going to accept by using this production, nothing but by using this context-free grammar. So the next one, generate all the strings of A's and B's where every string end with AB. Every string should end with AB. So nothing but the string should end with AB, but the starting can be anything. It can be a combination of A plus B whole star. I can have A's, or I can have B's, or I can have combination of A's and B's. So how I can write the grammar for it? How I can write the production for it, context-free grammar for it. So let me take yes. So every time I'm taking yes as my start symbol, we can take any letter, any non-terminal as a start symbol. Yes produces X, AB, XAB. Now again X I'm replacing it. X produces AX or BX or epsilon. X is replaced with AX, BX or epsilon. These X are nothing but the non-terminals. These X are nothing but the non-terminals. From these production rules, we can generate the context-free grammar. Nothing but a context-free grammar consists of the 4 tuples. So V is nothing but V is pointing to the capital letters S, comma X, and T is pointing to the terminal symbols A, comma B, comma epsilon. And production rules are nothing but these are the production rules. And the start symbol I am having is S is my start symbol. S is my start symbol. So this is nothing but the context-free grammar for the second question. So let us construct one more thing. Construct context-free grammar which accepts all the strings of A's and B's where every string start and end with same symbol. So here the question is the string should start with A and end with A. In middle I can have anything, any combination of A's and B's. And the other one is I can start with A, B and it can end with B. But it can have any combination of A's and B's. So the question is this one. It should start with same symbol and end with same symbol. If it is starting with A, it should end with A. If it is starting with B, it should end with B. And in between, the combinations of A's and B's can be there. So based on this, we are going to construct the production rule. Nothing but the context-free grammar. So let us take A plus B whole star A. Or we can have B, A plus B whole star B. So in this way, the grammar should be there. So let me replace it with some X. Okay, S produces A, X, A or B, X, B, S, B, X, B. So I can replace this X with A, X or B, X or epsilon. B, X or epsilon. So here this common one I have replaced it with. If I take this string, this production rule, then starting with A and ending with A. If I take this production, it is starting with A and starting with B and ending with B. So this is the context-free grammar production rules for the string that should start and end with the same symbol. So for this we can construct the 4 tuples, nothing but the context-free grammar. V is pointing to the set of non-terminals, nothing but capital letters. Here I have S, comma X. And T is pointing to the terminal symbols. The terminal symbols are A, comma B, comma epsilon. And the starting symbol is S is my start symbol. And P is nothing but the production rules of these 2 production rules comes over here. So this is nothing but the context-free grammar. A context-free grammar consists of 4 tuples. V, T, P, S. The production rules will be in the form of alpha produces beta. Alpha is nothing but LHS produces RHS. The LHS will consisting of only a single non-terminal, that is nothing but only a one capital letter. Wherever I find that non-terminal in the string, that will be replaced with the right side production, nothing but beta. So beta can be RHS part, can be a terminal symbol or epsilon, or it can be a combination of terminals and non-terminals or non-terminals followed by terminals. So the context-free language. The context-free language is nothing but the set of all strings that are generated from context-free grammar. We have generated context-free grammar. So while we are going to generate the context-free grammar by using these production rules, we are going to generate some set of strings. So that set of strings are nothing but we are going to call it as a context-free language. See here, it is a set of strings that are generated by a context-free grammar. So the context-free grammar is nothing but it is going to give you the set of rules. By using those rules, we are going to generate all the valid strings. Nothing but the set of rules are nothing but here the production rules. By using these production rules, we are going to generate some set of strings. So that set of strings, we are all valid strings. So that is nothing but we are going to call it as a context-free language. See here one example. S produces A, S, B or epsilon. This generates strings like, suppose this is going to generate the strings like this. So nothing but these are the set of strings which we are going to generate. So for this we can construct the context-free language. See here I have n is greater than or equal to 0. So how these strings got? We can see here. S produces A, S, B or epsilon. This is my production. The first string I can get S produces epsilon I can take. So either this one or this one. So epsilon is generated. Next S produces A, S, B. So these is I can replace it with epsilon. A, B it is produced. And I can also the A, S, B. A again S I am replacing it with A, S, B, B. So nothing but these S is replaced with A, S, B. A, epsilon, B, B. So nothing but I got A, B, B. A, B. So in the same way, I can get 3A's, 3B's also. So on. So how it is? Number of A's and number of B's are same. Here 1A, 1B. Here 2A's, 2B's. Here 3A's, 3B's. 4A's, 4B's. So nothing but it is same. A power n and B power n. Where n is greater than or equal to 0. Where n is greater than or equal to 0. So the context-free language that is generated with the help of this context-free grammar. So the context-free grammar is going to give you the set of rules. By using those rules, we are going to generate the valid strings. All these valid strings, we are going to construct the context-free language. So we can also call it as CFL. So